Triangles. Weird stuff. Yeah, it's very strange. Um, the thing that you're getting into is classifying by angles, classifying by sides, finding missing angles, and using exterior angles and supplementary angles to find the missing angle of a triangle, as well as algebraically solving for another angle or a variable. I really wanted to start off with the vocabulary that you're going to need. That was acute. Oh, acute. Oh, it's so pretty. Oh. Right? And obtuse. These are classifying by angles. Whenever you're classifying by angles, you're always looking for the largest angle. It'd be easy to find the smallest one because every single triangle would end up being acute. You look at this triangle, smallest angle is 60, smallest angle is 44, smallest angle is 26, smallest angle is 32. So that means we have all four acute triangles? I think not. Every triangle is going to have an acute angle in it. That's why you have to classify it by its largest angle, because it's only going to have one largest, unless it's a certain type of triangle, which we're going to get to. Notice that this one has 3 equals. All right, so we know that all triangles are equal to 180. There are some other rules that follow along with triangles. The opposite of that angle will show you what type of triangle it is when you're classifying it by its sides. So if it has all the same angles, it'll have all the same sides. Cool. So we know that this one is acute. Looking at 57, 79, 44. Acute is smaller than 90, right is 90, and obtuse is larger than 90. I haven't seen anything with a degree symbol that says larger than 90 yet. The largest one I see is 79. That's still acute. Look at that. 3 different angles, 3 different side measures. All right, so you can see this is 90. And I would always just go ahead and put the symbol in there to represent 90 degrees. I think it's easier to see the symbol than the number 90. That's me. But we can see that the largest angle is 90 degrees, automatically making it a right triangle. And we can see that all of the angles measure differently, which means that all the sides are going to measure differently, which is a certain type of triangle as well. Looking through here, I can see that 128 is the largest. That's larger than 90, so that's going to be obtuse. Notice that there are 2 angles that are the same, 26 and 26, and those directly relate to the 2 sides that are identical, 2.5. All right, so when I'm saying like, okay, look at all the angles, they're different, or they're all the same, it's this type of triangle. So what we just did is we classified by its largest angle. Now what about if we classified by its sides? There are 3 words that are for that, and that is equilateral, equi is a word part for equal, lateral is side, side movement, sides. And then you have scalene, which nothing is the same. So scalene is the one that is the complete opposite of an equilateral. In between, you'll have an isosceles. Isosceles means that 2 things are the same. So let's go ahead and go through these 4 triangles again, naming them by their sides. Look at that. All 3 sides are the same. All 3 angles are the same. And just know that every equilateral will always be 60 degrees in each angle. So if you see 60 in the angles, you know all the sides are going to be the same, and you know it's an equilateral. So we have an acute equilateral. Saying an acute equilateral is redundant, because for an equilateral to be an equilateral, it has to have angles of 60 degrees, so they're always going to be acute. So it's kind of implied that when you say equilateral triangle that you have all acute angles. All right. I can see that none of these sides are the same, and I know that because all the degrees are not the same. So if they're not the same, none of them are the same. That means we have an acute scalene. All right, we got a 90 degree. That's how we got the right. I don't see anything that is the same. 11.2, 13.2, 7. None of the degrees are the same. Looks like we got a right scalene triangle. Oh, dang, look, there's two of them that are the same. It's about time we have an obtuse isosceles. Get some. I just wanted to show this one and just to reemphasize the symbols that are associated with geometry. Um, you can see that there are no symbols on this. That's showing that no angles are congruent, no sides are congruent, or anything. This is automatically a scalene, and we can assume that that is an obtuse angle. We don't have any proof that it is, other than it looks like it. Typically, if there's not a symbol that represents it, the most information you can answer from this is that it is a scalene triangle, because there are no symbols showing that the sides are congruent whatsoever. Whenever we move over to here, you can see that these two angles right here, are congruent because they correspond with these two sides. So if we have two angles that are congruent and two sides that are congruent, that definitely goes together with everything we said on the previous page, where if angles are the same, we're going to have the same amount of sides that are the same. So not all of them are the same, and not all of them are different. So we've got ourselves an isosceles. And all of these look acute. I could assume that they're acute, but there's no symbol saying that, or there's no degree measures. There's no symbol saying there's a right angle. So safe bet would be acute, but the most that we know is that it's isosceles. See, here's an example of a right angle. So we know that we have a right, and we're showing that none of the sides or angles are the same. Scalene. That one we can define because the largest angle is 90. If we had a 90 degree and an angle that was obtuse, you wouldn't be able to have a triangle, because there would already be over 180 degrees with only two angles and not three. You can see that two angles are the same, which corresponds with those two sides are the same, so that's good. We know that it's automatically an isosceles. We have the largest angle being a right angle. Fantastic. We know for a fact that's a right isosceles. That's a right scalene. The two up top, we can't confirm the obtuse or the acute, but we can definitely confirm scalene and isosceles. So whenever we were going through this, you asked, can I draw it? I said, absolutely. So acute isosceles. All right, so all three angles are acute. Heck yeah, it's possible. We just looked at some of those. Right isosceles. There you go. Acute scalene. So, I mean, basically, if you're just drawing a triangle like that with no symbols, it's going to be scalene. Or you could do this, showing that all sides are different. You have three different side measures. You may also see one that looks like this, showing you that all the angle measures are different as well. A right obtuse, you can see that this is classified by angle and angle. That is not going to be possible. Right is 90, and then obtuse is greater than 90. So no matter how we do this, it's always never going to equal exactly 180. The smallest obtuse angle you could do is 90.1. 90 plus 90.1 is 180.1, automatically not a triangle. So this is where we went back through the basics of finding a missing angle in a triangle. You know that all triangles are equal to 180. You said add up what you've got and subtract from 180. So we did 148 subtracted from 180. And I was like, get it? And you were like, what? And I was like, I know, I can't believe it. 32. Then the question I asked you after that was, how would you check it? And you were like, add them all up, and it should be 180. Always check it. Always check it. You have just made a mistake, and when you check it, you go like, oh dang, I made a mistake, instead of going, yeah, I got it, and then you test back a week later and you failed it because you made mistakes all over the place and didn't check it. I like that you wrote in 90 right here, and this is where we used our supplementary vocabulary, because if we know that that one angle is 122, then we know that its supplementary angle is going to be right here, x. So you said, okay, we got two angles. They're supposed to equal 180 when you add them up. How do you figure out what's left? You go 180 minus 122. I was like, what? And you're like, yeah. And I was like, dang. So we have x is 58. Now you got 58, 90, and e. You're like, okay. Well, now we're back in the situation on this problem as we started off with over here on this one. With that little blob floating there, and with the sun, turning into the sun with a little face. Oh, hello. So what we had to do was 90 plus 58, 148. It's like, dang, is it the same problem? And you were like, yeah. And I was like, what? And you were like, I know. And I think you know what I'm going to say next. Check that thing. 58 plus 90 plus 32 should equal 180. Okay, another one of the supplement things. You know that 117 plus this angle that I marked as x should equal 180. You, of course, said take 180 and subtract 117 to figure out what we got left. 63 degrees. Now, if you wanted to get crazy and you wanted to go ahead and mark all the angles, that's perfectly fine. But we also know that you have to figure out what r is. 6r plus 1. And you know that whenever you add up all the angles of a triangle, you're supposed to get 180. This is how you write an equation. Alright, so 56 plus 63 plus 6r plus 1. See, look, there's the three angles. Angle 1, angle 2, angle 3. It's supposed to equal 180. Combine the like terms. So that should be 64, 60, 120. I think. I'm just going to check it. Yes. Plus 6r equals 180. Now we're solving a two-step equation. This process is going to be the same over and over. So get rid of the number first. With the variable by itself. 6r equals 60. Divide by 6. R equals 10. Alright, so if you're looking for R, you found it. I like what you said about, well, if I'm looking for the degrees, couldn't I just add up 63 and 56 and subtract from 180? I know how many degrees this is. Yes, absolutely. This is how you find R. If you wanted to check if your degrees are correct, you could substitute R in right here. 6 times 10 is 60 plus 1 is 61. That should be 61. Now you can add up all three and double check your double check. Dang! That's like double check times 2. Wait. Yeah, something like that. 48 and 84. You said add these up. Subtract from 180. 48, 84. Wow, that was supposed to be a 2. 13, 132. So you can see how all this stuff that was a prerequisite skill during middle school is starting to come back. Hey, look at that. We have two angles that are the same. That means that these two sides are going to be the same, which means we have an isosceles triangle. The largest angle that we have in this triangle is 84 degrees. We have an acute isosceles. How about that? All right, so here are two problems that look a little different. The process is pretty much the same. It's just going to be what we did on all the previous stuff, except you're solving for a variable at the end. So we already know that 86, 47, 4r plus 3. You're going to add all three of these up. We're looking for r. Notice we're looking for r, because yes, you could do your 86 plus 47, subtract from 180 and get the degrees. You know what? It'd be a good way to check is if we just do that right now. 86, 47, 3, 1, 12, 133. All right, so 180 minus 133, 7, 4. This should be 47. Let's find out if it is. All right, so we got 133 by adding up 86 and 47. So I'm not going to skip any steps. I just want to show you what's going on. 47 plus 4r plus 3 equals 180. So when we added up 86 and 47 up here, we got 133. Plus 3 is 136. Subtract 136. For r equals 44. Divide by 4. R equals 11. 4 times 11 is 44, plus 3 is 47. Check. This is where you need to look for this angle. That way you can know what you have. All right? Or you can do what you said. 25 and 36. 61. Subtract it from 180. 119. So we have an obvious 119 right there. What we do know is that whenever we add this and this together, we get this straight line. That straight line is equal to 180 degrees. So we could do 2z plus 1 plus 119 equals 180. Ooh, that works out nice. Look at that. 1 plus 119. 2z plus 120 equals 180. We are now solving the two-step equation. Minus 120. Wow, that's a 2. Minus 120. 2z equals 60. Divide by 2. Z equals 30. Okay? So we should be able to check that as well. 2 times 30 is 60 plus 1. It should be 61. 61 plus 119 equals 180. Check, 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 check. 30. The paper that I'm going to send along with this video is definitely going to help you practice doing this over and over and over.